Hello, I'm Mr. McBrien. This is SCH3U percent composition. The Ontario curriculum states that students will be able to explain the law of definite proportions. This law implies the idea of percent composition, and this is what we'll talk about today. We're going to cover the law of definite proportions, talk about percentage in general, percent composition in chemicals, and of course do our moles and molar mass quiz. So the law of definite proportions states that a chemical compound always contains the same proportion of elements by mass. And this is easiest to understand when we talk about a given example. If we take copper carbonate samples, we can take them from anywhere around the world, and they're going to contain the same proportions of copper, carbon, and oxygen by mass. So it's this concept that we're going to discuss today, talking about percent composition. Quick review of percent, of course. Literally, it's per 100. We talk about percent every day, a 3% chance of winning ticket. 3 people out of 100 will win, in other words. 6% of drivers are accident-free. That kind of idea. Now we could talk as well about an idea like what percentage of the class plays hockey. Let's say that 7 of the 25 people in the room play hockey. That would give us 28% are hockey players. But what kind of a percent is this? Obviously that's a number percent. We're not interested in number percents primarily today. We're going to talk instead about mass percent. So let's use another example to illustrate how the number percent is different than mass percent. We can look at this group of fruit and describe what percentage of the fruit is grapes. There are 20 pieces of fruit, so we've got 17 grapes and 3 oranges. Well, multiply by 5, so we get 15% oranges and 85% grapes. And that's true, but what if we wanted to work by weight percent? By weight percent, there are far more oranges than there are grapes. So we're mainly going to talk about the weight percent case today. So percentage composition. Percentage composition is just a way of identifying the elements that are present in a compound as a mass percent of the total compound mass. And really it's pretty simple, and we can imagine that it's the way that it's done pretty easily. We take the mass of a given element that's in the compound, divide it by the total mass of the compound, and then multiply by 100 to convert to percent. And here it is in equation form. So our percent of a given element equals the mass of that element as it's present in the compound, divided by the total mass of the compound times 100%. So this could, I suppose, be theoretically really easy to determine, except that our molecular formula gives the ratio of elements by number. So if we take iron 3 oxide, it has 2 iron atoms for every 3 oxygen atoms. And to get the theoretical mass composition, then, we have to use the molar mass for each one of those elements to get it. We can't simply report it as a number. So let's consider a mole, even though we could consider atoms if we wanted to. It's just we're going to eliminate those pesky scientific notation numbers by doing so. Okay, so in a pure compound, what's the percent by mass? For example, oxygen in iron oxide. So the first thing we want to do is find the molar mass of the compound. Then we find the mass of oxygen in the compound, and then we divide it out. So the mass of oxygen, of course, we have to remember the coefficient 3. So multiply the molar mass of 16 for oxygen times 3 gives us 48 for the mass of oxygen in a mole of iron oxide. And the total mass, I haven't shown it, but the total mass is 159.7 grams. So this gives us 30.1%. In other words, iron oxide is 30.1% oxygen by weight. Let's do another example. What's the percent hydrogen in water by mass? Okay, the molar mass of the compound is 2 times the mass of hydrogen plus the mass of oxygen, or 18.02 in total. The mass of the hydrogen is of course just 2 times the mass of hydrogen, or 2.02 grams per mole. And we can divide that out, and we find that water is 11.2% hydrogen by mass. Okay, one more. Silver nitrate. In silver nitrate, what's the percent silver by mass? Molar mass of the compound, 169.87 grams per mole. Mass of silver, this time the coefficient of silver, of course, is just 1. So the mass of silver is 107.87 grams per mole. Divide it out, and we find that silver nitrate is 63.502% silver by weight. Okay, so those are theoretical percent compositions. But we can also get those values by experiment, as long as we keep in mind one very important concept, the law of conservation of mass. So in any chemical reaction, the mass of the reactants will equal the mass of the products. If you think about that for a second, it's pretty logical. Mass isn't created or destroyed. So if we take a reaction of A plus B to C plus D, the mass of A plus the mass of B, in other words, the mass of the reactants, is equal to the mass of C plus D, or the mass of the products. Now we can use that law of conservation of mass to determine the mass of the components in a given compound, as long as we have done some appropriate measurements. So we can take this example. We weighed phosphorus, 4 grams of it. We reacted it with oxygen, and the resulting material weighed 7.21 grams. Well, we had 4 grams of phosphorus. We wound up with 7.21 grams of the new material. Where did the rest of the weight come from? Well, it had to have come from oxygen. So then we can use that to get the percent oxygen by mass. So will that experimental value precisely match the theoretical one? Well, we've already seen many times in our labs that it won't. And we've also seen how to do percent error calculations. We take the absolute value of the experimental value minus the theoretical value over the theoretical value, and this gives us a measure of how well we matched what we thought we were going to get, or what we feel we should have gotten. So let's do one example before we wrap up. We react calcium with oxygen to make calcium oxide. And we started with 4 grams of calcium. We measured the weight of the oxide that resulted, and it was 5.51 grams. We can get the percent oxygen very easily. All of the new material, the new mass, results from oxygen. So 5.51 grams minus 4 grams gives us the mass of oxygen, divided by the mass of the final product gives us the percent oxygen by weight, or 27.4%. But that's the experimental value. We can get the theoretical value by using the molar mass of calcium and oxygen. And if we do that, we get a theoretical value of 28.6%. We can then calculate the experimental value very easily. It's just the absolute value of 28.6 minus 27.4 over 28.6 times 100%, or 4.2%. Okay, try a few of these please on your own using the percent composition worksheet. What did we do today? Today we talked about the law of definite proportions and talked about how to calculate percentage composition in chemicals, whether from an experimental or a theoretical point of view. So for your homework tonight, please read textbook section 6.1 and do problems page 260. Thanks very much and have a great night.